Okay, so good afternoon. So today we're looking at the sum of formula for arithmetic and geometric patterns. Normally if this question comes in, the question is worth between 4 and 5 marks, either 4 or 5 marks for this question. It doesn't always come in, it could come. Okay. So we'll start off with a proof of the arithmetic sequence, sum of formula. This formula is given on the formula sheet. Okay. But as I said, at times I would ask you to prove the sum of formula. So the sum of formula for this is arithmetic, where Sn is your sum of terms, your A is your first term, your N is your position or term number, and D is your common difference. Okay. So where do we start? We're firstly saying, but okay, that is RTP is required to prove. Okay. So we start off by saying that we know the sum of terms will be the first term plus the second term, which is A plus D, plus the third term, which is A plus 2D, and A plus 3D, and all the way. Okay. Where the last term is A plus N minus 1D. Okay. Now the term prior to that, the term before that, it's going to be A plus N minus 2D. Okay. I'm going to write this a bit smaller so we can fit more in. So the first term is A plus D, A plus 2D. The last term, we said is going to be A plus N minus 1D. The term prior to that is going to be A plus N minus 2D plus A plus N minus 3D and so on. Okay? Remember, this is your last term, or this is your nth term, Tn. Not so? So what happens is we take this whole sequence, A plus D, A plus 2D, all the whole sequence. And we take this whole sequence and we flip it around. So the last term is first, and the first term is last. And so on. Okay. So it would still remain Sn. Not so? If the last term is first, it's A plus N minus 1D. The second last term is second, so A plus N minus 2D, plus and so on. The last term being A, the second last term being A plus D, A plus 2D, and so on. Okay. So what we do now is we rule a line. Okay. And what we do now is we add that thing. So what is Sn plus Sn? 2Sn. Remember, we're going to add these. It's going to be 2Sn. So we add those two terms. So what is A plus? What's A plus N minus 1D? 2A. Will be 2A plus N minus 1D. I'm going to put a block bracket because I see you've got the round bracket. Can you see that? So let's add these two terms. So that's going to be 2A plus N minus 1, which I wrote down here. What will happen if I take A plus D plus a plus n minus 2d? 2a plus? Okay, so here's the issue here. So let's multiply this out. I'm going to get a plus d plus a plus nd minus 2d. What is a plus a? 2a. Plus nd minus d. What do you notice here? Common factor of d. So it's n minus 1d. Hang on, that's in the same. Not so. So it's going to be 2a plus n minus 1d. What do you think will happen if I add that term to the third term? Same story. It's 2a plus n minus 1d. And so on and so on. That will repeat itself. Even with the last term, if I add this here, it will be 2a plus n minus 1d. And so on and so on. You guys understand? What's going to happen if I add the second last one? Same thing. So how many of these brackets will there be? A lot. Can't say a lot. 5. What does these dots between it mean? It carries on till the last term, and the second last term, and the third last term. So the number of terms between it is dependent on how many terms there are in the sequence. How many terms are in the sequence? N amount of terms. So how many times will this be repeated? N amount of terms. You understand? So in other words, you have 2 Sn is equal to n amount of times of 2a plus n minus 1d. But what was the question? To prove Sn or 2Sn? Sn. So what do I do? Divide by 2 throughout. So therefore, Sn is equal to n over 2 into 2a plus n minus 1d. Okay. But they can variate this question as well. They could ask you something different. They could have asked you to prove Sn is equal to n over 2 into a plus l. What's the difference between these two formulas? 1 over l. It's obvious. No? Can't be more obvious than that. But the L is what? The last term. So if they ask you this instead of what they asked you here, what you can do is you can say, okay, the last term is this here. Is this not the last term?
Yes.
Answer? So what we do is we say, okay, you first go and you prove what we just proved now. First go and we prove what we just proved now. Stuff is not playing along today. It's tired already. He just want to write maths and get done. No?
Mm-hmm.
Yeah, that's tomorrow, don't worry. So in other words, I must get this here somewhere. Can you see that? So in other words, that's where we'll stop if that was the question. But we can say Sn is equal to n over 2 into 2a is the same as a plus a. Not so. So it's a plus n minus 1d. Where this here is your last term. Not so. So you can calculate therefore Sn is equal to n over 2 into a plus. That's how they get the second formula. Okay? But majority of the time they'll ask you this one here. So if this one is asked, what we do is we just add this onto it and we got the formula they asked us to prove.
So if they ask us to prove, we write it exactly like that.
So exactly like this. It should get you up until here 6 marks. Otherwise, up until here, 4 or 5 marks.
So what if I ask you now for that, do the first one and then you do the second one?
All the way to the second one, they rule a line and they give you the marks. You see, we are nice people. Don't believe in nice people. Huh? Not at all. How much I now feel? Right, but you understand? This question comes in definite 4 or 5 marks. What do you say, sorry, man? People, the other one. So remember, this is for the sum of arithmetic. There's a common difference. Okay. Another way they could have asked us, instead of saying required to prove, let me just draw your attention to this here. They could have asked you, prove the formula. Exactly that what we did in the first case. N is equal to 1 for n amount of terms, where Tn, with the general term, is a plus n minus 1d is equal to n over 2 into 2a plus n minus 1. They will ask you prove. You all should agree you're going to do the same thing. Why? Because this is the general term and this is the sum of terms. Not so? You're going to do exactly the same thing.
So if they give me something like this, must I do that exactly?
Exactly the same thing as we did before. Exactly the same.
So then you just see prove, and you just like exactly.
Exactly the same thing. They're asking you the same question they ask you. They ask you prove this. They ask you to prove the formula. Okay? This is another way of asking you the same thing. What? It's the same thing. You don't have to write it down. You just got 24 hours to remember. Less than 24 hours. After that, you don't need it again in your life, isn't it? Right. Let's look at the other one. We are asked, you are required to prove RTP. Not our IP, no? Maths must rest in peace, you say. RTP required to prove that Sn is equal to A into 1 minus R to the n over 1 minus R. This is exactly the same. What will happen if I swap this around? A negative comes up. So it's negative A into R to the n minus 1. If I swap this around, what's going to happen? Negative is going to come out. It's going to be R minus 1. The negatives cancel. So it's A. R minus 1 over A into R, n minus 1 over R minus 1. It's exactly the same thing. Okay? I think the formula sheet has this one on it. If I'm not mistaken. Okay? Just check that. I mean, last time, look at this.
The other one.
Oh, it is the second one.
Yes.
Okay. See? If you use the formula enough times, you will start memorizing the formula. Okay, so when you guys always go to a formula sheet, I know why. I just don't say anything. Okay? So I know you didn't use the formula enough times. Okay, and she has a formula sheet on her phone. Yeah, your wallpaper. Oh, you're busy with the class. Okay. So, let's go with this here. As I said, they could have asked you this one, or they could have swapped it around and asked you that. It's the same. It's the same thing you're going to do. Okay? So where do we start? The different color first. Okay, so, nice. People normally next to this, they will say R is not equal to 1. Why do you think they will tell you that R is not equal to 1?
Otherwise you can't be undefined.
The denominator will be undefined. Not so? And the denominator cannot be undefined. Otherwise, you're not going to get a sum of formula, the sum of terms. Not so? So, as we did before, we're going to first say what? The sum of terms are. So, Sn is going to be the first term plus the second term plus the third term plus till the nth term. Not so? So, the first term is what? A. The second term? You multiply by R. AR. Third term? AR squared. Fourth term, AR cubed. And so on. The last term, AR n minus 1. This was now the nth term, the last term. Second last term, AR n minus 2. The third last term, AR n minus 3. And so on and so on and so on. Not so. In arithmetic, what we did was we swapped the whole term around, the whole sequence around. First became last, last became first. For the geometric progression, we multiply this whole line here by r, by a factor or a ratio of r. By multiplying this with r, what do we get? Sn times r? R Sn. Not so? You with me? No. What is A times R? AR. But what I'm going to do is I'm going to put like terms one below the other. Okay? Which means to say, I'm going to say, A times R is AR and it's going to go under that. It was like terms. Not so. So A times R is AR. A times R is AR times R? Which is going to go under that one. Not so. Like this, I want to make it too confusing, yeah? It's going to be AR squared. The next one is going to be AR cubed. And the next one, AR4 and so on and so on. Not so. What is the last term? AR n minus 1 times R. If I multiply the last term by R, what do you think we're going to get? AR n minus 1 plus 1, which is AR n. If I multiply this AR n minus 2 by R to the 1, what am I going to get? AR n minus 2 plus 1, which is AR n minus 1. So this one here, this one is going to go under the last term, not so. That is going to go under here. Why? It's like terms. So where's this one going to go? It's in a category of its own. Does it make sense? So, let's take all this stuff out here. So here, we said if it's AR n minus 2 times R, it's going to give you AR n minus 1. If I multiply the term prior to that there with AR n minus 2, I will get AR n minus 1. If I multiply the last term by R, I'm going to get R to the n, AR to the n. Does it make sense? So what do I do now? Again we rule a line. Okay, and this is exactly the reason why they taught you how to rule lines in grade 1. To get to this point in your life. Now what do we do? What do you notice? We are going to add these terms. Remember, in the first proof, we added together, we got the bracket that we ended up with. Do you think we're going to add here together? No. No? But rather make so not so. Why not? Because that's something going to become bigger. There's no pattern that will follow. However, if we change the signs on the line, we change, so if we multiply throughout this whole second line by negative, 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 what's going to happen here? What is Sn minus R Sn? What's Sn minus R Sn? Stays like it. Why? They are unlike terms. You're not left with R. No? Yeah, I know in your heart you're saying, say R, say R. No, it's not R. Why? Because they're unlike terms. You say, okay, there's no couple with A. So I put A on its own. What is AR minus AR?
0.
Can't go. AR squared minus AR? Gone. AR n minus 2 minus AR n minus 2. Cancel. AR n minus 1 with AR gone. So what are we left with? Plus. Minus. Yes, what's wrong with you? Minus ARN.
Yeah.
So there's the minus. Not so? I say, hang on. Say, hang on. But what do we notice here on the left hand side? Is a common factor. Yes, the great tens know. Common factor. What are we left with? Oh, is Asima sitting? That would be great. Yes. 1 minus. Oh. I say, okay, let's try the same on that side. What do we see here? A is common. We left with 1 minus r to the n. Do you think they gave you factorization in grade 9 unnecessary? Everything comes together. Okay? So stop telling yourselves, when I'm in grade 12, I'm going to start working, mustn't I? That was what you guys grade 12 think. When you're in grade 12, I'm going to start working. Then you're already 5 years behind with your maths. No? Right, so how do I get SN on its own? Divided by 1 minus r. That's gone. So SN is equal to a 1 minus r to the n over 1 minus. And of course r is never equal to. Okay, you got it? Yes? It will be safer, rather write it in, because that's your restriction. Even if they don't tell you to write it in, or they don't put it next to the proof, you put it. You say, oh, this girl, or this child, knows what they're talking about. Okay. It was done if you're a girl or a boy. Maybe from the handwriting and the colors you use. No? But further than that, we don't know. We don't know which school you're coming from. We don't know who you are. You probably just know how old you are. No, we don't even know. You know ID number even. Was this your matric number? Okay. People, they could have also asked you for the sum to infinity, but I haven't seen that coming. Okay, so I'd rather leave it now.
I was mistaken.
Alright.